Well, folks, this is Guruji-Online, and in the last lecture of free body diagram, we have analyzed the forces on the block which is resting on horizontal surface, whether that surface is smooth or it is having friction. Now, in this video, we are going to analyze the forces on the block which is resting on an inclined plane, and we will see if that surface is smooth or if that surface is having friction. And this is how we will try to analyze the forces on the block. And also we will see if the inclined wedge on which the block is resting, if it is moving, then what is the difference in the analyzed forces? So let us start one by one. Here you can see this is a block of mass M which is resting on a inclined plane, and this inclined plane is smooth. Correct. Now suppose this block is sliding with acceleration A, then let us analyze the forces on this. Here, of course, there will be a gravitational force due to mass of the block, and there will be a reaction due to the plane on which this mass is resting. This is R, and if we extend it, then naturally this will be theta. And if we analyze, or if we resolve this gravitational force, then this will be mg cos theta, and this will be mg sin theta. I hope this is clear. And this way, R is nothing but mg cos theta, and what about this? What is the force as the block is moving with acceleration A? Means the force on the block is nothing but MA, and this must be equal to your mg sin theta. Correct. So this way, A you are getting as mg g sin theta, means this is the effective acceleration which is acting on the block, and due to which it is moving with acceleration A down the slope. Now let us see, this plane is friction. it is having friction. Of course, mass of the block is m, and this is theta. Then we can resolve these forces like in the previous example. Mg cos theta and mg sin theta. Of course, there will be reaction. And now, when it is moving downwards with acceleration A, naturally there will be a frictional force which will be acting on this, which will be opposing the motion of the block. Here, again, R will be mg cos theta, and F is nothing but mu R or mu mg cos theta. Now, since the block is moving downward, that means your mg sin theta force along the plane is more than your frictional force. This must be equal to your. So in this case, your A is nothing but G sin theta minus mu G cos theta, or we can write it as G correct. So this is the effective acceleration down the slope you will get. But suppose in case of limiting equilibrium, means suppose this block is resting on this and there is a frictional force, and of course along this side mg sin theta will be there. So what can be the angle in case of limiting equilibrium? Means it is just about to slide, and when it is just about to slide, your mg sin theta must be equal to F, or you from here this will be nothing but G sin theta minus mu cos theta. If we equate it to 0, then what will be? Your mu will be nothing but tan theta. That means this is constant for any surface, mu. So you can find out the angle at which the block will be able to slide. Correct? So this is the angle at which it will be able to slide. Now let us see another example. Suppose here again your block is there, and in this case suppose it is moving with acceleration a in the upward direction. Means upward means along the plane in the upward direction. So it is very simple. Just dissolve the forces. With reaction R. Now since it is going upward, so your F friction force, actually it is having friction. The friction force will also act in this direction. So in this case, what will happen? And your F will be nothing but mu R mu mg cos theta, or your, since block is moving upwards, that means your MA must be equal to mg sin theta plus, because now mg sin theta and F, they are in the same direction, acting downwards. So that means A will be now in this case sin theta plus mu cos theta when the block is moving up. Correct? Now let us take one more example where this inclined plane it is moving. Suppose this is moving with acceleration b in this direction, and it will have mg sin theta, and this surface is suppose smooth. So there will be these forces. We can resolve this. Mg cos theta, mg sin theta. Of course, there will be reaction. Now, what will change on this block if you make the free body diagram? So on this block, there will be a force like this due to this acceleration, or it will also have this mb force on this. Correct? So if we resolve this force along the plane and perpendicular to the plane, then what will happen? This will be your theta. That means this is mb cos theta, and this will be perpendicular plane. This will be mb sin theta. It will be in the same direction. I hope you understood this. So suppose this block is moving down the plane, then naturally MA will be nothing but mg sin theta minus mb cos theta. Correct? And here, what will be your R? R will be nothing but mg cos theta plus mb sin theta. Your reaction will increase due to acceleration of the inclined plane. And here A is nothing but your g sin theta minus b cos theta. Sorry, it will not be this. This bracket will not be there. B cos theta. Now we can find out a condition. Suppose A is 0, means block is at rest. What is the acceleration of inclined plane so that the block on it should remain at rest? So this we can find out like this. Or B will be nothing but G. So if we move the inclined plane with an acceleration g tan theta, then the block M, which is resting on this, it will remain at rest. It will not move. This is how, in simple terms, with the use of free body diagram, we can find out the acceleration, forces, and all this. This is how we can analyze this inclined plane.